So in the previous video, we looked at the relationship between moles and particles, and we looked at some calculations about how to do them. In this video, we're going to look at molar mass and its relationship with mole. So most often than not, we're using molar mass to find the mass of a particular substance. So let's take a look. So molar mass, to begin with, is the mass of 1 mole of a substance. So in order to compare all of the different elements on the periodic table, what they have done is taken 1 mole of a substance and weighed it. So you know how they are different in their mass. The symbol for molar mass is M, right? So just like you would say the symbol for time is T, if you're referring to molar mass, a shorter way of doing that is to reference it as capital M. And the unit for molar mass is grams per mole. And as we look at the conversion factor, or using molar mass as a conversion factor, that's going to make a lot more sense. So how do we find the molar mass of a substance? It's actually on the periodic table. What we refer to, or what we have referred to up until now as the atomic mass, is what we call molar mass from now on. So the molar mass of nitrogen, which is over here, is 14.01 grams per mole. Another example, molar mass of magnesium, 24.31 grams per mole. So your periodic table is where you can find the molar mass of all of these elements. But how would we find the molar mass of a compound like this? So the simple answer is you have to take into account the molar mass of each element and how many of that element there are. So calcium is over here, has a molar mass of 40.08. So 40.08 grams per mole times 3, because there's 3 calcium there. Plus, so we have to look at the next element, which is phosphorus, and there are 2 phosphorus here. So 30.97 times 2. Oops, okay, let me just write this a little bit better. So this times 3, 30.97 grams per mole times 2 plus oxygen, which has a molar mass of 16.00 grams per mole, times 4, there's 8 oxygens here. And then you have to just solve this. So this will give me 120.2 plus 61.94 plus 128, which if I add up together, I will get 310.18 grams per mole. And you don't have to look at significant digits for molar mass. We're always going to reference it in 2 decimal places. And this is how you'd find the molar mass of calcium phosphate. Now, on an assessment or a quiz, you don't have to show me the full process of doing it just because I want you to be very, very quick with it. But please make sure that you're accounting for the molar mass of each element and then accounting for how many of that element there are. So if you're writing this as a conversion factor, you would write, so there's 2 possible ways that you can write this, right? So you can write 310.18 grams for every 1 mole, or you could write 1 mole over 310.18 grams, right? And this is true for every molar mass for every compound. The only thing that will change is the actual number for the mass itself, right? So if you are finding the molar mass of, say, magnesium chloride, the mass of that, this value here, instead of writing 310.18, is going to be a different number. But the way that you represent it is still in these two possibilities. You would still, if you want to cancel out the mole and get grams, you would write moles on the bottom. And if you wanted to cancel out the grams, you would write the grams on the bottom. Okay, so having learned that, let's take a look at a few examples on how to do this. So calculate the number of moles in 3.0 grams of magnesium chloride. Okay, as we did always, or as we keep doing, you always have to write the number that you are given in the question. So I'm given 3.0 grams. And what I want to do is I want to calculate the number of moles. So I want to get to the moles at the end. So I need to find a value that has the grams at the bottom and moles at the top. So as we saw earlier, we would do it this way. Grams at the bottom, moles at the top. However, we're not talking about calcium phosphate anymore. We are talking about magnesium chloride. So what you would have to do is find the molar mass of magnesium chloride. So molar mass of magnesium plus molar mass of chlorine times 2. And if you add those all together, you'd find the molar mass of magnesium chloride. So let's take a look. Go back to our periodic table. Magnesium has a molar mass of 24.31 and chlorine has 35.45. So 24.31 plus 35.45 times 2. So if I take out my calculator, 35.45 times 2 plus 24.31 will give me 95.21 grams per mole. Now, this is the value of our molar mass, and what we have to do is represent this in a way that helps our situation. So in this case, the grams is on the bottom, which would mean 95.21 grams, and then the moles is on the top, so that's 1 mole. That's the exact same thing that you're representing here. So you're saying 95.21 grams for every 1 mole. You're just representing it in this way here so that our units can work out. So you have our grams, our unit of grams will cancel out, and your final answer is going to be 0.03150, but we always have to keep in mind our significant digits. In this case, we've got 2 significant digits, so I need to round to this number. And the number that's right beside it is a 5, so 0.032 moles of MgCl2. Okay, so this is my final answer. Let's take a look at another question in which we are given the value of moles and then we have to find the mass. So the number that I'm given in the question is 1.43 times 10 to the power of -2 moles. And then what I have to do is solve for the mass. So solve for grams. So I need the moles on the bottom so that the moles can cancel out. And I need a value of grams at the top. So I have to find my molar mass so that I can write it like this. My molar mass of this compound will depend on the 3 elements, which are potassium plus oxygen plus hydrogen. So let's go back to our periodic table and take a look. So hydrogen has a molar mass of 1.01, oxygen has a molar mass of 16, and potassium has 39.10. So potassium 39.10, oxygen 16.00, and hydrogen 1.01. Because there's only one of each of these elements, all I would have to do is just add these up. So 39.10 plus 16 plus 1.01 will give me 56.11 grams per mole. In this case, the grams has to be written at the top, so 56.11 grams for every 1 mole. So writing it this way, I have to multiply 1.43 times 10 to the power of negative 2. So 1.43 times 10 to the power of negative 2 times 56.11, which will give me 0.802373. There are 2 significant digits in my question, so I only need 2 significant digits in my answer. So my answer is going to be 0.80 grams. Oh, there are 3 significant digits in my question, sorry. So there are 3 significant digits in my answer, so my answer is going to be 0.802 grams. And that's it.